The light bulbs in this image are connected in parallel. When you connect electrical devices this way, each component has an independent path back to the voltage source, which means if one of the light bulbs in the circuit goes out, the other bulb will remain lit. In a parallel circuit, each component has its own circular path back to the source. The circuit here has 18 amps of current coming out of the source. As it travels through the circuit, the total current separates into 3 branches. The total current coming from the source is equal to the sum of the currents in each branch. For instance, if a parallel circuit has 3 branches with the following currents, the total current from the source must equal 9 amps. The voltage source in the circuit creates an electrical field around each resistor, which causes each resistor to have the same voltage drop. Since the voltage drops are equal, we can now fill in the unknown voltages for each resistor. Ohm's law states that the voltage of each resistor equals the current times the resistance. The current in the first resistor must be 4 amps, since 4 times 5 is 20. The second current is also 4 amps for the same reason. Since the total current coming from the source is 18 amps, and the currents in the first 2 branches add up to 8 amps, the last branch must have 10 amps of current. Since the voltage equals the current times the resistance in the third branch is 2 ohms. Let's go over this solution again. The voltage drops in each resistor in parallel is equal to the source, in this case 20 volts. We can find the unknown current in the first resistor because voltage equals the product of current and resistance. We can find the current in the third branch using the total current. Ohm's law gives us the value in the last resistor.